In this video, I will explain the concept of momentum and impulse. I will start with a comparison between kinematics and dynamics. In kinematics, you remember acceleration, changing velocity in every second. Now let's multiply acceleration by mass. Here we get force, F equals ma. So force can be considered as the big brother of acceleration, the big brother in dynamics. You remember velocity, displacement in every second. Now let's do the same thing with velocity. Multiply velocity by mass, you will get momentum. So what the momentum is the product of mass and velocity. Is the momentum a vector quantity? Yes, it is. The direction of velocity and direction of momentum will be always the same. What the unit of momentum is, in SI it would be kilogram meter per second. Kilogram for mass, meter per second for velocity. You remember average acceleration was delta V over delta T. And here I can write average force delta P over delta T. You see they have the same role. Big brothers are on the right side and little brothers left side. As I mentioned, momentum is a vector quantity. It's affected not only by mass but also by velocity. It has direction. Let's say we have a toy truck, a small toy truck with a mass of 10 kilograms. And then it's moving at a speed of or a velocity of 4 meters per second to the right. So the momentum of this truck will be 4 times 10 kilogram meter per second to the right. If I double the mass, let's say the mass is 20 kilogram, now we can say the momentum is doubled also, 80. You know that it's affected by mass. And if I triple the velocity, let's say the velocity is 12, so the momentum will be 10 times 12, so it's 120. As you see, this momentum also is the triple of the previous momentum, the original momentum it had. So we can say if I double the mass, if I triple the mass, if I double the velocity, if I triple the velocity, it will happen for the momentum also. Let's have an example. A ball of mass 0.25 kilogram is moving to the right at a speed of 7.4 meters per second. It strikes the wall at 90 degrees and rebounds from the wall, leaving it with a speed of 5.8 meters per second moving to the left. You see the rebounding speed is different from the initial speed. Calculate the momentum of the ball before it strikes the wall. Let's do it first. This is the ball moving to the right. I suppose it's moving to the right. And then momentum would be mass times velocity. The mass is given to be 0.25 and the initial velocity 7.4 to the right. So P1 is going to be 1.85 kilogram meter per second. Positive sign here, positive sign of the momentum, as I already consider the right side to be positive direction, indicates that the momentum is to the right. Part B, the change in the momentum after the ball strikes the wall. Change in momentum is not momentum, but it's delta P. So I should find P2 minus P1. I know the P1, but I don't know anything about P2. The second, the rebounding momentum. So let's find it. P2 is going to be mv2. As velocity, initial velocity is 7.4 to the right, so the rebounding velocity is negative 5.8 because it's to the left. So I will consider a negative sign for the second velocity after it rebounds. So it's going to be negative 1.45 kilogram meter per second. Now I can find the change in momentum, P2 minus P1. Consider all the negative and positive signs. This is the second momentum. This is the first momentum. This is the first momentum. So it's P2 minus P1. The answer is negative 3.3 kilogram meter per second. Negative sign indicates that change in momentum is a vector to the left. Now let me introduce the concept of impulse. You remember we had F equals delta P over delta T, rate of change in momentum. Now we rearrange the equation and write it as delta P equals F delta T. This delta P is called impulse. That's also impulse is nothing but changing momentum. The unit of impulse could be the same unit as the momentum, kilogram meter per second, or if you want, Newton times second. But what do we mean by F delta t? There is an object is acted by a force of 100 Newton, and the total time the force acting on the object, let's say, is 2 seconds. So the impulse on this object will be F delta t, 100 times 2. So it's 200 Newton second. This is a very easy understanding of impulse based on force and the time of the force, the time that the force is acting on the object. Moreover, if you have a force T graph, whatever it is, it could be even a kinked graph like this, the area under the graph can easily be proved to be J, the impulse. Look at this diagram. On the left side, we have VT graph and AT graph. This AT graph is different thing. It's not the AT graph of this velocity time graph. So consider them in different perspectives. In this VT graph, the slope is acceleration. We learned it in kinematics. Now I multiply the vertical axis by mass. So on vertical, I have momentum. Here, VT is converted to PT graph. And also, the slope of that is multiplied by mass. Here, the slope is acceleration, and so the slope here must be force. So the slope of PT graph is force. Now let's consider acceleration time graph. The area under the graph is change in velocity. We know that from kinematics. Now we multiply the vertical axis by mass. So acceleration is converted to big brother, the force. The area under the graph also is multiplied by mass. The area was delta V, now it's multiplied by mass, so it's m delta V or delta P. Delta P, you know, is also J, the impulse. Jonathan strikes a tennis ball moving with a horizontal initial velocity of 45 meters per second. This is the initial velocity, let's say it's positive to the right. The ball leaves the racket in the opposite direction at a speed of 65, so it's to the left. The mass of the ball is given to be 58 grams, so it's going to be 58 times 10 to negative 3 kilogram in SI units. Calculate the magnitude of impulse that the racket delivered to the ball. The ball is in contact with the racket for 20 milliseconds. Guys, this milli is also 10 to negative 3. Be very careful. Okay, let's start. Magnitude of impulse means that you just need the absolute value of delta V. So it's m delta V, or the same as delta P. So what should I do? Inside this absolute value, I have delta V. Delta V seems to be V2 minus V1. V2 is negative 65. Guys, you see that it's to the left, so it must have a negative sign. If I take the 45 to be positive, so it's minus 45. This is V1, and this is totally V2. This is what you will apply inside the absolute value. So here I have V2 minus V1. And behind that, I have 58 times 10 to negative 3. I've converted the mass to SI units. The answer is 6.4 Newton second. This is the J, the impulse. Part B. Calculate the average force that the racket exerted on the ball. The average force is going to be F, delta P over delta T. We already found delta P, so it's 6.4. Delta T is 20 milliseconds, this milli, 10 to negative 3. So the answer seems to be 320 Newton. Now also it's a very useful practice to find the direction of force. You remember I got the positive direction to be to the right, okay? So here I have the initial momentum to be P1 to the right and the final momentum P2 to the left, okay? So I draw them from the common tail. So here I have P1 and here I have P2. When you write delta P means P2 minus P1. To find the direction of this subtraction, I should connect the end of P1 to the end of P2. End of P1 to the end of P2. This is the delta P. So the direction of the delta P is to the left. This is why we consider the direction of force also to the left. The force time graph of an object is given in the following cases. In which case do we see larger impulse on the object? You remember the impulse was the area under the FT graph. If I have FT graph, the area under the graph is the impulse. So the one which has the largest area under the graph will be the answer. What's your opinion? Correct. Number 1. It has the largest area under the graph. So the largest delta P or the largest J impulse. The graph shows how the force acting on an object varies with time. Look at the graph. It is force time graph. The mass of the object is 50 kilogram. Mass is given to be 50. I take a note. Its initial speed is 0. So it starts from rest. Calculate the final speed of the object. What's your opinion? How can we find the final speed? Think about it. I told you we have a brotherhood. The velocity has a brother which is called momentum. So if I have the momentum, as I know the mass, I can find the speed. Momentum is related to the change in momentum. Change in momentum is delta Pj. And J is the area under the graph. FT graph will give us the delta P. Good. So the approach is like this. I will find the area under the graph, which is m delta V. Out of that, because I know the mass, I can find the delta V. Delta V is V minus V naught. Forget about V naught. It starts from rest. So V will be the final goal. Let's do it. Here I have J, m delta V, and here the area of the trapezoid. Area of trapezoid is very easy here. Here I have the larger base, 25, plus smaller base, 15, times height. Height is 15, divided by 2. This is something you see here. Left side, mass 50 times delta V. If I find the delta V, it's done. Okay, upstairs is 40. Divided by 2 is 20. 20 times 15 is 300. So 50 times delta V is 300. Let's use V instead of delta V as I mentioned. So V is going to be 300 divided by 50, which is 6 meters per second. The graph shows how the momentum of an object of mass 40 kilogram varies with time. This is momentum time graph. Momentum changes linearly to 200 in 10 seconds. Explain why the acceleration of the object remains constant. Guys, if the acceleration is constant, so the brother force is constant. If I prove that force is constant, I can go back and take the result of constant acceleration. So how to do that? This is the momentum PT graph, and you know that the slope of this PT graph is delta P over delta T, which is the force. You know that this is a line, and in math, we know that line has constant slope. So line in PT graph means constant slope means constant force. This is why the acceleration is constant. So in short, I can say PT graph is a line. Line has a constant slope. The slope is force. So the force acting on the object is constant. So acceleration is constant. Part B. Calculate the acceleration of the object. Acceleration is the little brother of force. Force is ma. If I know the force, I can find the acceleration because mass is given. Let's do it. F is delta P over delta T, as I mentioned, is the slope. Here I have delta P, which is 200. Here I have delta T, which is 10. So it's 200 divided by 10, 20. Then I use the Newton's second law, ma. I import the mass from here, 40 kilograms. So acceleration seems to be 20 divided by 40. So it's 0.5, a half of meter per second square. I shortly introduce kinetic energy because the next question is related to kinetic energy. Kinetic energy is the energy due to motion. And the formula we can use for that is a half of mv squared, M is the mass of the object and v is the speed. Kinetic energy is totally independent of direction of motion because it's sensitive to speed, not velocity. Because the speed also is raised to the power of 2, it can't be sensitive to negative or positive sign. Kinetic energy actually is in SI is measured in units of joule. More than that, it's always a positive quantity. Now let's consider this example. An impulse J acts on an object of mass m. It's a parametric question, initially at rest. So the initial speed is 0. Determine the kinetic energy gained by the object. Actually, I'm looking for kinetic energy, but based on the given parameters J and m. I'm going to use the previous formula and combine them. J is delta P. It's something that I mentioned. J is going to be m delta V likewise. And so delta V is J divided by m. I separate delta V into V minus V naught. And V naught is 0 because the object starts from rest. Okay, so V is J divided by m. On the other hand, I know that kinetic energy is a half of mv squared. Then I import the speed here. So I can write it's a half of m J divided by mass to the power of 2. And then I can kill one of the masses in upstairs and downstairs and find J squared divided by 2m. This is an alternative formula for kinetic energy. It's not a very complicated formula and you don't have to memorize it. It was just an example because in the upcoming videos I will consider the relationship between kinetic energy and conservation of momentum and also the momentum. So we should know something about kinetic energy. This is why I mentioned. Thank you for watching this video and thank you for being with me. See you.